Okay, chapter 9 is going to be about hypothesis testing. So we are going to start out with some basic fundamental properties of it. So, for instance, what is a hypothesis? Well, um, we often use inferential statistics to make judgments about things. That's the focus of the scientific method with a hypothesis. One of the most common methods is to perform a hypothesis test. Now, a hypothesis is a statement that something is true. So, with hypothesis testing, you typically have two hypotheses. You have a null hypothesis and the alternative hypothesis. Now, the null is what we're testing. It's basically, it represents what we're testing, and it's represented by h sub 0. The alternative is a hypothesis considered as an alternative to the null. And I know that's hard to believe, but that's what it's considered, okay? Alternative to the null. And it is represented by h sub a. Now, the hypothesis test, this is the problem in a hypothesis test, the problem in a hypothesis test is to decide whether the null should be rejected in favor of the alternative. That is your goal, to decide whether the null should be rejected in favor of the alternative. So, we have some guidelines for choosing these two hypotheses. A null hypothesis. In this book, the null hypothesis for a test concerning a population mean always specifies a single value for that parameter. Hence, we always express the null like so, where mu sub 0 is some number. Always going to express the null like this with this particular book, okay? It can change from book to book, but for this one, we're going to express it like this. As for the alternative, you basically have three choices for the alternative. Not equal to, which means it's a completely different value. The alternative is a completely different value from the null. We call the not equal to a two-tailed test. Okay, you have when the alternative is less than. Okay, when the population mean is less than the specified value, that's what we call a left-tailed test. And when the population mean is greater than the specified value, that's what we call a right-tailed test. A hypothesis test is called a one-tailed test if it's either left or right-tailed. Okay, won't see many of those in this class. We will mainly see two-tailed, left-tailed, and right-tailed. All right, so let's look at an example here. A snack food company produces a 454-gram bag of pretzels. Although the actual net weight deviates slightly from 454 and vary from one bag to another, the company insists that the mean net weight is 454. As part of its program, the Quality Assurance Department periodically performs a hypothesis test to determine whether the packing machine is working properly. That is, to decide whether the mean is 454. Alright, so letter A. Determine the null hypothesis for the test. Well, what is the mean? The mean is 454. So our null is going to be written h sub 0 is the population mean equals 454 grams. That would be our null hypothesis. Now, for this particular test, what would be an alternative? Well, we're trying to make sure, what's the goal? We're trying to make sure that mean is 454. So the alternative would be if the mean does not equal 454. Does that make sense? If the goal is to determine if it equals 454, the mean would be not equal. Now, classify the test. Which one is it? Is it a two-tail, left tail, or right tail? Well, when it's not equal to, we know that a not equal to is a two-tailed test. Not equal to is a two-tailed test. So basically what our alternative is saying there is that the machine is not working properly. Okay, that's basically what the alternative is saying. Alright, so let's look at another one. Alright, so we have a company collects information on retail prices of books. In 2005, the mean retail price of history books was $78 and a penny. Excuse me. Suppose that we want to perform a hypothesis test to decide whether this year's mean has increased. Now, there's a key here, and I'm going to go ahead and underline it. Has increased, okay? So, determine the null. Okay, what is the null? What are we trying to determine that the population mean equals? Well, they told us what the mean equaled. The mean equaled $78 and a penny. Now, what is the alternative here? What is the alternative? Well, the alternative is that this year's mean price is greater than 78. That's why I underlined has increased, because what we're trying to say is that this year's price is greater than the 2005 mean. So our actual alternative here would be greater than 78.01. Alright, so when it's greater than, what tailed test is it? Well, it is a right-tailed test when it is greater than, because we know that by the greater than sign. Alright, let's try another one. Okay, so calcium is the most abundant mineral in the human body and has several important functions. Most body calcium is stored in the bones and teeth, where it functions to support their structure. Recommendations for calcium are provided in dietary reference intakes developed by the Institute of Medicine of the National Academy of Sciences. The recommended adequate intake, the RAI, of calcium for adults is 1,000 milligrams per day. Suppose that we want to perform a hypothesis test to decide whether the average adult has an income below the poverty level, with an income below the poverty level, gets less than, now there's a key right there, less than the RAI of 1,000. So what is our null? Our null is what the mean is. So what is the mean? Well, it's 1,000 milligrams. Less than serves as our indicator for the alternative. So our alternative is going to be, less than 1,000 milligrams. Okay? Our alternative is going to be less than. So how would we explain that? Well, the alternative hypothesis is the mean calcium intake of all adults with incomes below the poverty level is less than the RAI of 1,000 milligrams per day. That's how we would describe that alternative. Now, what is the what kind of test is this? Well, it's less than, so we know it's a left-tailed test. Okay, so you will develop writing these based on the articles and things. You will begin to get pretty involved in that and be able to do that pretty much in your sleep probably. But the one thing that you're going to want to pay close attention to is how would you describe it? How would you describe it in English? The alternative. What does it mean? For instance, on this last one, the alternative is the mean calcium intake of adults with income below the poverty level is less than the RAI of 1,000 milligrams per day. That is what that alternative means. So be able to write out what they mean as well. Now, we have some logic with hypothesis testing, and it's pretty common sense, but we write it down anyway. Take a random sample from the population. If the sample data are consistent with the null, do not reject the null. If the sample data are inconsistent with the null and supportive of the alternative, reject the null in favor of the alternative. I know that that's kind of common sense, but you would be surprised. So just don't overthink this. Please don't overthink it. That's where people have a tendency what people have a tendency to do with this. So anytime you make a decision based on partial information, which is sample data, we're making a lot of these decisions based on sample data, you have a chance to be incorrect. I mean, you have two types of errors typically with these hypothesis tests. You have a type 1 and type 2. And a type 1 is when you reject the null when it's actually true. Type 2 is not rejecting the null when it's false. So, for instance, if you look at our little table here, if the null is true and we don't reject it, that's a correct decision. If the null is true and we reject the null, that's the type 1 error. If the null is false and we don't reject it, well, that's what we call a type 2 error. But if the null is false and we do reject it, that's a correct decision. Okay? So keep that in mind. Type 1, type 2 errors. So let's go back to our quality assurance problem with the 454 grams of pretzel packing. What would a type 1 error be? What would a type 1 error be? Well, a type 1 error is when we reject the null when it's actually true. Okay? Type 1 is when we reject the null when it's actually true. So in this case, type 1 error would occur when it actually equals 454, but the results of sampling give us a different conclusion. So, for instance, you could sample all this data and get the conclusion that it's not true, but it actually is. That's what happens when you're sampling. You're not getting the full picture. So that's a type 1 error when we reject the null and it's actually true. A type 2 error is when we don't reject the null and it's false. So what would that mean to us? Well, a type 2 error is when would occur if it doesn't equal 454, but the results of our sampling says it does. Okay, so if you're doing the sample and it actually looks like it's true, but it's not, that's a type 2 error. Okay, and that's caused by the results of sampling. As I said, that's the game we play as humans when we sample, when we make our decisions based on samples instead of populations. There's a chance at having some error. What would a correct decision be? Well, there's two kind of correct decisions. If the null is true and we accept it, that's a correct decision. If the null is false and we reject it, and the data supports that, the sample conclusions support that. That is in fact a correct decision. Now suppose that the results of carrying out the hypothesis test lead to rejection of the null. So we rejected it. That is that the population mean does not equal 454. Classify that conclusion by error type or correct decision if. Okay? So, does it have error or is it a correct decision if the mean net weight is in fact 454? So if we've done our sampling and we get it to equal this, we get it, we find out by our sampling that it's not 454, but the mean actually is. So if we reject it and it's actually true, in other words, so that would be a type 1 error. A type 1 error because we've rejected a null that's actually true. Well, what if it's not 454? Well, if we got the conclusion that it's not 454 and the fact that it's not 454, that means we rejected it, so it was a correct decision. Our data supported correct decision, if I can spell that correctly. Our data supported our decision. Okay, that's what's going to be important for you to learn about statistics. Data-driven decision making. Make sure you have a supportable conclusion. Okay. So probabilities of type 1 and type 2 errors. What are the chances of making an incorrect decision with a hypothesis test? That's what we're asking. What are the chances of making an incorrect decision? Well, the probability of making a type 1 error, meaning we reject a true null, is called the significance level alpha. A type 2 error occurs if a false null is not rejected. That type 2 error is a beta. Okay, is the probability, has the probability beta. Okay, type 2 error probability is denoted by beta. So, what's the relationship between these two? Well, think of it like this. For a fixed sample size, the smaller we specify alpha, the larger will be the probability of beta. Okay, of not rejecting a false. So, think about what we're saying there. If alpha is very small, okay, alpha is rejecting a true. So if the probability of rejecting a true is really, really small, then the probability of not rejecting a false is going to be really, really high. Because if the probability of not rejecting a true is small, then that means you're accepting everything. You're accepting everything. So it might make your probability, so it will make your probability of not rejecting a false very high because you're accepting so much. Okay, so watch the relationships. There's a paragraph or two in your book on that that you need to read. Some things you just need to read. Doing on the video is not going to help you at all. I would definitely read those last couple of pages of section 9.1. I think it will help give you an idea of the relationship between these probabilities. Okay, type 1 and type 2 errors. Statistically significant versus not statistically significant. Well, let's suppose we have a small significance level. If the null is rejected, then we can conclude that the data sufficiently has evidence to support the alternative. If you have sufficient evidence to support the alternative, we say that it's statistically significant, that you have statistically significant evidence. If you do not reject the null and the data does not provide significant evidence, then we say it's not statistically significant. Okay, so keep that in mind as this is more of a terminology lesson. As you hear me say things like statistically significant, not statistically significant, and so on. All right. Okay, y'all have a great day. If you have any questions on hypothesis testing, make sure to ask your